single stage air compressor without, very important, without clearance volume. Clearance volume, very important. Single stage air compressor without clearance volume. You know what is meant by stroke volume? You know what is meant by clearance volume? You know, right? We have discussed in IC engineering, right? The same only, no change at all. I will draw here. Okay. What is the name of this one? All of you. Piston. What is the name of this one? Counting. What is the name of this one? Crankshaft. What is the name of this one? Cylinder. This is my TDC. What it means? Top dead center. There is no what volume? I'll draw one more. Okay. This is my BDC. The distance between TDC to BDC, what we call? The distance between TDC to BDC. Total volume we call, remember? Stroke volume. Stroke. Hey, stroke length. Stroke length. Then what about this volume? We have two type volume. We have VC, VS. Do we have VC here? No, because the VC is nothing but the smallest volume when the piston is at TDC. Now piston is at TDC here, right? Yes or no? Then where is the clearance volume? No, we don't have clearance volume. So this volume is called stroke volume. The volume between TDC to BDC is called stroke volume, sept volume, displacement volume. All are same. All are same. This is stroke length. So here we don't have clearance volume. Correct? Single stage. Why is a single stage? Why is a single stage? Why it is a single stage? We have only one cylinder. Got it? Single stage. We have only one cylinder. If I have one more cylinder here, then it becomes multi-cylinder, two stage. What we call two stage. Since I have only one cylinder, it is single stage. Why air compressor? Yeah, here we compress air. So it's a air compressor without clearance volume. Do we have clearance volume? No. Have you understood the heading? So single stage air compressor without clearance volume. This is single stage air compressor without clearance volume. How this air compressor works, that we need to understand first. Then I will draw the PV diagram. Okay? Okay. Normally, we need to have the valves, right? Amalia. So here also we will be having valves. One valve will be here, it will be located here. The other valve will be located here. Here no exhaust. What we call here? Outlet. Another name, tell me. No. Delivery. What we call? Delivery valve. This is suction valve or inlet valve. This is delivery valve. Okay, how it works? We need to understand. This, very important, understand. These two valves. This is, I will take inlet valve or suction valve. This I will take delivery valve. Okay? Very important. You have to understand one thing. These two valves are spring-loaded valves. What we call? Spring-loaded. Based on the pressure deviation. Based on the pressure deviation, this valve open and closes. Understood? Based on pressure. But in IC we have seen how it works. Based on the camshaft. Based on the camshaft. But here we don't have camshaft. We have only spring-loaded valves. Spring-loaded valves. Okay. Now assume your piston is at TDC. Your piston is at TDC. The piston moves from TDC to BDC slowly. So then what will happen? Vacuum will be created inside the cylinder. We discussed, right? Vacuum will be created inside the cylinder. Due to vacuum pressure, this inlet valve get opens. Whenever there is a vacuum pressure inside the cylinder, whenever there is a vacuum pressure, this cylinder, this inlet valve will get opens. That's how it is designed for air compressor. Got it? So it opens, piston moves from TDC to BDC, keep on it moves till BDC, the inlet valve will open. In our study, now we are studying about without clearance volume. Got it? Got it? Here no clearance volume. In practical, if you see any industry, all compressors are having with clearance volume only. All compressors with the clearance volume. But for study case, to compare how effective without clearance with the clearance, what is the effect of clearance volume on air compressor? If clearance volume is more, what is the effect? In order to study, we are arriving no clearance volume. Understood? But in practical, not possible. All compressors has what? Clearance volume. More the clearance volume, question mark. Less the clearance volume, again question mark. That's how to compare we are arriving this. Understood? Any doubts? Irukku. Clearance volume irukku. நீ சொன்ன மாதிரி இருக்கும். எங்கேயும் போகாது. Okay? Understood? So happens. Once the piston reaches to BDC, both inlet valve and exhaust valve remains, both inlet valve and delivery valve remains closed. How, sir? It will remain closed only. It remains closed only. When piston moves from DC to TDC, the vacuum pressure becomes high pressure. Due to that high pressure, this valve what will happen? Get closed. Because the rule is whenever vacuum pressure, you just open. Otherwise, don't open. Otherwise, don't open. When the pressure increases, this valve remains closed only. Got it? Then, when this delivery valve get opens, yeah, that's very important because how many strokes do we have here? Only 2 strokes. Suction, compression. Then where is the delivery? Where is the delivery? Clear? So, all the compressors are designed for a particular pressure. This compressor 10 bar pressure, this compressor 20 bar pressure, this compressor 5 bar pressure. So based on design pressure of air compressor, this valve will be designed. This valve will be designed. If this compressor designed for 10 bar pressure, this valve is designed for 10 bar load. Got it? Whenever there is a 10 bar inside the cylinder, what of this valve? Opens. Whenever 10 bar, this valve get opens. So it means I compress from here to BDC to TDC 1 bar, 2 bar, 3 bar, 4 bar, 5 bar, 6 bar, 7 bar, 8 bar, 9 bar. It will attain 10 bar here itself. It will attain 10 bar here itself. Further, it compresses. What happens? Valve will opens. Valve will opens. Then what will happen? The air will take delivery. It will escape from the cylinder. So during from here to here, how the pressure will be? Low, high, or same? Same. Very good, man. Same. The pressure remains same one because whatever pressure is increased, no, the same amount of air by volume or mass will be escaped from the cylinder. Got it? So it will maintain same 10 bar only. It will maintain same 10 bar only. So what happens? We have stroke 1 completely suction. Stroke 2 compression till here. Then delivery. Understood? Then delivery. So suction, compression, delivery. Only 2 stroke. Only 2 stroke. Understood? So for this, I will draw one PV diagram. I will have one small derivation also. We will solve one small derivation also. So first we will draw one PV diagram. Okay. So for better understanding, always we go for the PV diagram. This is P. This is V. There is no clearance volume. There is no clearance volume. I am going to draw actual diagram and theoretical diagram. Both I am going to draw. Okay. For actual I use yellow color. For theoretical I use pink color. Got it? Since no clearance volume, this is my starting position, right? This is my TDC. Yes or no? Yes or no? These are TDC. Let's take here we have BDC. The same pistons arrangement, you invert here, okay? You invert here. Got it? So when piston moves from TDC to BDC, theoretically, no, first we'll study actually. I will draw one arrow mark. Actually, what will happen? When piston moves from TDC to BDC, what will create here? What will create? Vacuum will create. Vacuum pressure will create. Due to vacuum pressure, the inlet valve get opens. That to maintain the same vacuum pressure till the piston reaches to BDC. Generally, the air will come. Even if you go to doctor, no, if you want to take blood from our body, what will do? We'll keep on drag till, okay? Blood rate will under blood or move blood pressure since it has to compensate the vacuum pressure inside the cylinder. And the vacuum pressure compensate பண்ற வரைக்கும் என்ன ஆயிட்டு இருக்கும் air வந்து உள்ள வந்துட்டே தான் இருக்கும் keep on it will enter so it will maintain this is actual right it will maintain vacuum pressure got it will maintain vacuum pressure that's what we see in IC engines maintain vacuum pressure but for study case what we take constant pressure suction. For study case, we'll take constant pressure suction. Got it? So let's take this is our A, this is our 1. Once piston is to BDC, it start to move again TDC, right? So both valve will get closed due to the pressure. Got it? Then what happen? Pressure increases. Temperature increases. Volume decreases. So this compression is called polytropic compression. What we call actual one. We have seen no where PV is equal to constant, PV power N is equal to constant, PV power gamma is equal to constant. PV power 1 irukku actually 1 irukku. We have seen the class. So your N will be greater than 1, less than gamma. I will explain manna. Super experiment. 3 process. First one, what type of process? Isothermal process. Second one, polytropic process. Third one, adiabatic process. This is very slow process. This is very fast process, rapid process. Where there is no heat transfer. Sorry, there is no change in temperature, but heat transfer is there. But here there is no heat transfer, but change in temperature is there. Got it? We have seen about it. So this compression is called polytropic compression. What are compression? Polytropic compression. A curve. Okay, a curve. Polytropic compression. This happens till the piston reaches to display. Here it attains 10 bar. How much bar? 10 bar. As we have seen. This is 1 bar. This is 1 bar for our compressor. Once it attains 10 bar, what happens? Delivery valve opens, delivery takes place. Okay? So as I told you, in theoretical, I'm telling theoretical. So here it will maintain high pressure. It will maintain high pressure only till the total amount of air sent to the delivery side. Got it? So, but theoretically, we cancel this. We will take constant pressure delivery only. Okay? For both are same only for actual. Okay? Both are same only. Okay? Got it? I am going to erase the actual diagram. Sorry, theoretical diagram. We'll keep only actual diagram. So, in case they ask comparison, you draw the comparison. Okay? You draw the comparison. So, this is my 1. This is my 2. This is my A. I'll take this is my B. Got it? Suction, compression, delivery. Got it? We have to write now. A to 1 is a what? Suction. I'm sorry. A to 1 suction. 1 to 2 compression. 2 to 3 delivery. Got it? Any doubts here? Any doubts here? Any doubts? This 2 you understood, right? If you understood this 2, the rest of entire unit is free. Entire unit is free. Now how to derive the equation for this one? How to derive the equation for this one is very simple. I will tell you, okay? Let's take how many processes we have here? How many processes? 3 processes. 1 section, 1 compression, 1 delivery. These 3 combined together, we can't derive the equation. We can't derive the equation. So we have to derive by step, okay? So what will I take? I will take this is I will take A, B, I will take 0, I will take C, okay? Here, so which means I am going to draw one yellow line here or white line I will take, that will be better. This one, right? So A, B, C, I will put D here. See, we have 3 areas. I know, I hope you have seen the 3 areas, right? So, area, we have 1 to BA. Similarly, we have area 2B 0D. Similarly, area A1C0. I have seen 3 areas. Because the work given to the compressor only this area. The work given to the compressor only this area is work given to the compressor. Got it? We need to find out how much work is given to the air compressor. Only this area. Got it? To get this area, which one should be added, which one should be deleted from our areas? I have first area, I have written here 1 to DC. This complete area I have taken. Okay? First area. Second area I have taken 2BO. This complete area I have taken. Third area I have taken 1A1CO. So which one should be added, which one should be deleted? Which means we have area 1 2BA plus 2BOD minus A1CO. If you do like this, can we get the work done? So here I put W of compressor, okay? W in of compressor area, I'll put like this. Got it? Oh, sorry. First one 1 to DC. Okay, 1 to DC. I'm sorry. First one 1 to DC. Now it's clear, right? So first area only we are taking this area only. Okay, it's not a B and C. Got it? Now it's very simple. W in, we substitute all the equation. We know PV power N is equal to constant. We derive the equation. Do you remember? What is the equation? For this, we derive the work done equation in thermodynamics, polytropic. P2 V2 minus P1 V1 divided by N minus 1. Marandachi. What to do? Ellame Marandachi. Got it? First equation. What type of process is one? This one. Constant pressure delivery. This one constant pressure suction. So constant pressure delivery, we add what we add P2 V2 minus PB VB. Based on notation, we have to choose there. What we have to choose that. Okay. Minus what we have. This one. Okay. What we have P1 V1 minus PA VA. Got it? One polytropic, 2 constant pressure. I know, I'm sorry, my VB is equal to VA. Volume is constant, not pressure. I'm sorry. Got it? See, here volume is 0. VA volume is 0. VB volume also 0. Both are 0 only. Got it? Amalya, volume is 0. If this volume is 0, 0 and this volume is 0, 0 multiply anything becomes 0. 0 multiply anything becomes 0. So rewrite this equation P2 V2 minus P1 V1 divided by n minus 1 plus P2 V2 minus P1 V1. Got it? Got it? Got it? Any doubts here? Any doubts? No. Now same P2 V2 P1 V1. P2 V2 P1 V1 will take outside. P2 V2 minus P1 V1 with the bracket. Here will take 1 by n minus 1 plus 1. Got it? Do LCM. What we have? P2 V2 minus P1 V1 1 plus n minus 1 divided by n minus 1. This one will get cancelled. Your final equation will become Wn is equal to, first we will write this one, okay? First we will write this one. What is this one? N by n minus 1 P2 V2 minus P1 V1. Got it? Any doubts? Any doubts? Any doubts? What is our PV is equal to? PV is equal to what? MR T. We will substitute now. W in is equal to n by n minus 1. MR is constant. Shall we take outside? Shall we take outside? MR is constant. We will take outside. The equation becomes T2 minus T1. So this is equation 1. This is equation 2. In case they are not given in volume, in terms of volume, in terms of temperature, then what happens? If they are given in terms of pressure, in polytropic T2 divided by T1 is equal to P2 by P1 what? N minus 1 divided by N. That is adiabatic. This is polytropic. So W in is equal to N by N minus 1. MR, take this T1 outside. This becomes T2 divided by T1 minus 1. Got it? Take this T1 outside. T2 minus T divided by T1 minus 1 will become, right? So here you substitute that equation, you will get the W in is equal to N by N minus 1 MR T1 P2 divided by P1 whole power N minus 1 divided by N minus 1. That's it. This is your equation 3. Whatever you know right, that you can based on, you can take it. If you know in terms of pressure and volume, use this equation. If you know temperature, use this equation. If you know pressure, use this equation. Okay? So we have now 3 equations. Based on that, we can proceed our problems.